Good morning, students. Today, let us see Unit 2 Syntax Analysis. The various topics in that syntax analysis are role of parser, grammars, error handling, context free grammars, writing a grammar, top down parsing, general strategies, recursive design parser, predictive parser, LL1, shift reduce parser, LR parser, LR of 0, item construction of SLR parsing table, introduction to LALR parser, error handling and recovery in syntax analyzer, and YAC. Now, the role of the parser. The first phase of our compiler is our scanner, lexical analyzer. Okay, the input to the scanner is the source code, the output is the various tokens. Scanner will identify very simple errors. Right, so the role of the parser is it performs context free syntax analysis, it guides context sensitive analysis, it constructs an intermediate representation, it produces meaningful error messages, it attempts various error correction. Now the second phase is the syntax analysis, right? Now here the context-free grammar is used. It consists of 4 components VTPS. V is a set of terminals, okay? N is a set of non-terminals. Then we are having the starting symbol. Then we are having a set of productions. Okay, these are the notations used here. Now, what are the notations? All small case letters will act as terminals, right? Special characters will act as terminals. The capital letters will act as non-terminals, right? So, we have single step derivation and the multi-step derivation, you call it as sentential form. Each and every step, you call it as a sentence of the grammar. You have two types of derivation, rightmost derivation and leftmost derivation. Now, in the syntax analysis, grammars are often written in the Backus normal form. Right? In a Backus normal form, for a grammar, we represent non-terminals with capital letters, terminals with typewriter font or underline, and productions as in the given example. Right, so scanning versus parsing. Now in our scanner lexical analyzer we use regular expression, whereas in our parsing we are going to use a context free grammar. Right, so let us see the various parts in our grammars. That is, you have ambiguous grammar and unambiguous grammar. Right, so we have two types of parser, top down parser and bottom up parser. So LL of K, it comes under predictive parser, top down parser. The first L stands for left to right derivation and second L stands for leftmost derivation. Then under the bottom up parser we have LR, SLR and LALR. Okay, first L stands for left to right and second stands for rightmost derivation. K is the number of tokens as look ahead. Then we have simple SLR, right? Then we have look ahead LR. Now under our grouping of these hierarchy of grammar classes, you can find that LL of 0, LR of 0, SLR, LALR, then LR of 1 and LR of K. Now next is a recursive design parser. Right, we can produce a simple recursive design parser from a right associative grammar using this given algorithm. Right, next is our building the tree. One of the key jobs of the parser is to build an intermediate representation of the source code. Right, so now here if you find it to build an abstract syntax tree, we can simply insert the code. So we have factor, term, expression and goal. Right, non-recursive predictive parsing. Our recursive design parser encodes state information in its runtime stack or call stack. Using recursive procedure calls to implement a stack abstraction may not be particularly efficient. So we go for other implementation method, explicit stack and stack based method. Under non-recursive predictive parsing, right, we are having the scanner, then tokens are given to the table driven parser, which is using stack and the parsing tables. Right, so it is if you see here we have two types of parsers, top down parser and bottom up parser. Thank you, students.